Hello, ladies and gentlemen. My name is Kurt, and I would like to introduce you to Juno. As you know, earlier this month, I traveled to Florida to Kennedy Space Center as an invited guest to their Juno NASA Tweet-Up, where we heard talks from all of the main mission scientists. We got to tour Kennedy Space Center, and then we finally, on that Friday, got to see the Juno spacecraft launch on its Atlas V rocket, which was an amazing experience, my first rocket launch in person, so it was absolutely amazing. And as promised, although way behind schedule, I am going to be making a quick video to let all of you know what I learned at the NASA Tweet-Up about the Juno spacecraft, and show you around this new program called Eyes on the Solar System. It was made by NASA JPL, and actually, the team who created this was also at the Juno NASA Tweet-Up, and they gave us a brief introduction and tour of this kind of nifty software. If you have been following me for quite a while, you know I did a few videos in a program called Celestia, which is kind of a solar system universe simulator in a 3D environment that lets you learn about the universe. It's a really cool tool, but unfortunately, since it is an open source software and all of the new items being put into it are made by users, they didn't have any updates for the Juno spacecraft. So that is why I came to the Eyes on the Solar System program, where it's coming straight from the horse's mouth. This is by the people at NASA JPL. They are the ones who are in charge of many, if not all, of the exploration missions for NASA. So that it's a really cool program. It itself is still in beta, so there might be some issues I might come across here. I've tried this a couple times and it's crashed a few times. It's a pretty big program, but I'll put a link in the video description. The cool thing about it, though, is you don't need to install anything other than the web player. This all runs on the web browser, so you can install it on any computer you have and enjoy it yourself if you'd like. But let me talk a little bit more about Juno here. As you may already know, Juno is on its way to Jupiter, which it will not reach until 2016. So that gives you a sense of scale as to how far away, first of all, Jupiter is, but also how much time and energy it takes to get there. Juno is, as you can see, solar powered. It has these 3 solar arrays. It is the first exploration spacecraft to go to the outer solar system, and when they say outer solar system, it's anything Jupiter, Saturn, and beyond. Basically because when you get out to that level, it's the sun is so far away that you don't get much power from solar panels, but they decided to save on costs and, you know, to test the limits of solar panels, that they would, instead of making this spacecraft nuclear powered like the Cassini, the New Horizons, all those other deep space missions, they made it solar paneled, which is, it's kind of a cool little engineering feat that they had there. And I can actually show you. You can't see, obviously we're in deep space here. There's the sun. The Earth is behind us there. We have Neptune, New Horizons. There's Jupiter, which is way out there. But let me give you a sense of scale. Kind of a cool thing in this program is it allows you to compare the size of objects to, you know, well-known features that you can kind of correlate in your brain with. But Juno is no small piece of hardware. It is, it's pretty big. Like, there is a scientist and or just the standard human being standing next to Juno there. So it's a pretty gigantic piece of hardware. Obviously, when it launched, these solar panels were folded in because it had to fit into the Atlas V housing up on the top there. And then once successfully launched, these solar panels deployed, they tested them, and they're receiving light. Each of these individual cells, one of which they actually brought one of the testing cells with them to the NASA Tweet-Up, which is kind of cool, but they're some of the most efficient solar cells ever developed. So that's really quite cool. We can also compare it to the size of, what are we doing here, a school bus? Yeah, so there's a school bus, and there's Juno. Juno's pretty big. So let us, first of all, maybe they accidentally included a school bus in the Atlas V, and it's just out there in orbit. Ah, help us. But that's kind of a really cool tool. Here is, what is this? a stadium. Obviously, Juno is much smaller than a football stadium, but it's still pretty big. That would be better to compare to the size of the International Space Station, because the International Space Station is the size of 2 football fields if you take into account all of its solar panels. But anyway, let's go back to Juno here. And what I can do is head back in time. You can find out more information about Juno. They have all this interesting information, current location. What else do we got? Cool tools. We already saw that. What is this? Right now, Juno is 7,378,517,18,19,20 miles away from Earth. And that is, as of now, August 30th, 2011 at 8:18 p.m. Central Daylight Time. It's right now moving away from Earth at 11,317 miles per hour. So that is quite the speedy little spacecraft. Let me get back to Juno. Whoop! Well, I guess since we're in this view, we can compare how far we are from... Let me see. And bear with me here. I'm getting used to this. Whoops. This program. There we go. Let me look at spacecraft. I'm going to look at outer planet missions. Juno. Click to zoom. Alright, we're back at Juno. Let me rotate around here. Let me see if I can go back in time to when Juno launched. So give me a few seconds and I will be back with you when I figure out how to do this. Alright, we're back. I had a little bit of a mishap there and the program crashed, so I'm back in. And when you go to the Eyes on the Solar System program, there's a special feature all about Juno that you can click on that has all the milestones throughout. So that's how I had to get here. But let me go back to the launch view. Whee! Here comes the Earth into view. And here on the bottom is a timeline. What is this? I'm learning along with you guys. Okay, we are looking at Earth as it currently is. I would like to look at Earth while it launched. So let me... Aha! There we go. I was standing right there watching it launch. It obviously takes off into an Earth orbit. And then the upper stage of the Atlas V, the Centaur rocket, gives it a final boost that takes it out of Earth orbit. Whoa, Nelly! After which it separates and the solar panels deploy. They don't have that animation here, but it's all good. This is all in fast motion here. Juno doesn't spin this fast. It spins as fast as you previously saw. So here we go. Leaving Earth. So long. Never to return. Whoa. Juno leaves Earth's influence into a heliocentric orbit. Basically, it's going to go in front of the Earth, obviously, and it was really cool. I remember the next day after it launched, less than 24 hours later, NASA, the Juno Twitter, sent out a tweet that said, oh, now Juno's further away from the Earth than the Moon. So that was pretty crazy. That's a fast spacecraft. So let me see where else we are going here. I think I can zoom out. Yeah, there we go. Okay, so Juno, there's Earth, there's Earth's orbit. Let me see if I can hurry this up. And fast forward. Okay, here we go. Juno's kind of leaving the Earth here. This is in November of this year. Let me look at Juno. Thank you. Oh, not that close, actually. Zoom out. Zooming out from Juno. Let me get... Oop. Oop. Come on. You can do it. Slow down. I'm going too fast here. Whoa. Okay, let me go at real rate. And let me zoom out. Okay. In, what is this? July of 2012. Juno is way out past the orbit of Mars. So now let me, and just to give some scale, there's Earth. Ooh, it highlights. There's Juno. Here's Jupiter. That is quite a distance. And it's actually Juno. Let me fast forward things here. The interesting thing about Juno's orbit is in 2013, it's actually going to come back towards Earth. And if I can slow it down here, you can see it's following Earth. By doing that, it's actually getting a gravity assist from Earth, which is going to give it its final push. Oh, here it comes. Here comes the gravity assist. It's going to get really quite close to Earth, and as you see, it kind of modified the orbit there. And that is going to give it its final boost. And they do that because that saves on fuel, because by using the energy from the Earth's gravity, you don't have to carry all that extra fuel and rocket power up with you. So it's just kind of an economic way to send a spacecraft to the outer solar system. So we got our Earth gravity assist in November of 2013. And now we're heading out. And the cool thing is Juno has, if I can zoom in here, that's probably spinning too fast, but let me zoom in back to Juno. There we go. Shortcut. Let me see if I can find it on here. These are very accurate little models that they have here. All the experiments. I think that right there is what's known as the Juno cam. It's calibrated to take pictures of Jupiter. Obviously there's much less light out there, and Jupiter looks a lot different than Earth, but I think they're going to try to take a picture of Earth as it's flying by and getting that gravity assist, just as one last test of the mechanics of the systems on the camera and whatnot. And actually just today they released a photo. Juno turned around just to test it out and took a picture of the Earth and the Moon. It's, you know, they just appear as two little white pixels in the field of view, but it's really cool to see the Earth and the Moon from that far out. So that's Juno Cam, and that is purely, from what they tell us, a public outreach. It's not necessarily meant for any scientific purpose. They're going to hand over controls, quote unquote, hand over controls to school children who are chosen from certain schools, who will get to choose what to take pictures of when they're in Jupiter orbit. So that's a really cool thing. Otherwise, most and all of the other science experiments are located on the outsides here of Juno's panels. So, but we're going to talk about that in a second when we get to Jupiter. Let me try to zoom out one more time. Come on, you can do it. There we go. I think there's probably a shortcut I'm missing. So we've gotten our gravity assist from the Earth, and now we're going to speed up one more time. We are now in the, what is this, the cruise phase. As you can see, these different phases and events. There was the Earth flyby. Now we're heading on out. It's taking a long time. It's 2014, March, April. And one of the questions that somebody asked at the NASA Tweet Up to the scientists was, are you worried, because right here we're going through the asteroid belt, are you worried about hitting anything in the asteroid belt? And they basically came down to it's a negligible risk. As I mentioned in previous videos I've made, the asteroid belt isn't quite the sci-fi view of, you know, Star Wars, having to dodge all these asteroids and boulders in space. Even though there is quite a bit of material, it's all very small and spread out. Oop, we just lost Jupiter. There we go. It's all very spread out and small, so there is, you know, thousands, if not hundreds of thousands of miles between each individual particle of space in the asteroid belt. So they do account for small micrometeoroid hits, and they estimate a few % of the solar panels will be lost, but they've accounted that in with how much power they're going to need, and they just assume that they're going to lose some solar panels to either they fry out or they get hit by a micrometeoroid or things like that. But it's all, they think of these things way in advance. You know, these people, the Juno's been in development for almost 10 years. Obviously, it's going to take another 5 years to get to Jupiter, and then once it's in Jupiter orbit, it's going to be doing science for another year. So these scientists and engineers put a good chunk of their entire career into this project. So they think of pretty much everything. But anyway, here we come on April 2016. Let me slow down a little bit. We're catching up with Jupiter, or Jupiter's catching up with Juno. Whoop. And as we can start to get closer, we can see all of Jupiter's 50 some odd moons that they have. And unlike Cassini or other missions like Voyager and New Horizons, we're not going to be, we, as in, you know, as if I'm involved with the Juno spacecraft, it's not going to be, Juno isn't going to be studying any of the moons. It's purely there to study Jupiter itself. They're going, all the instruments, they want to study and find out about the core of Jupiter. Basically because Jupiter is the largest, obviously most dense planet in the solar system, but also just located in Jupiter, there's more material and, you know, mass in Jupiter than can be found in the rest of the solar system, not counting the sun, obviously. So you can fit Earth and all the other planets and moons and asteroids and still not be the size, or the mass, excuse me, of Jupiter. So that's really quite cool. So the scientists feel, let me slow down a little bit, I'm taking my time. The scientists feel that since Jupiter is probably the first planet to have formed, just based on its density and its age, we can learn a lot about how all the other planets formed based on what we learned from Jupiter. So they're going to be studying the magnetic field, the radiation field. Jupiter has a gigantic magnetic field, and they might show us in this animation. But basically, the magnetic field of Jupiter stretches all the way out further behind it, past the orbit of Saturn. So it's quite a magnetic field. But anyway, here comes Juno into Jupiter, into its insertion orbit, which is probably what this says, Jupiter orbit insertion. It's not going to be in a perfectly circular orbit. It's going to be kind of in an oddball elliptical orbit. Let's do this. Actually, whoa, slow down. Let me zoom in, because it's really cool. They also, nope, not Jupiter. They also have the animation for, slow down there, Juno. Yep, they have the animation for when the rocket is going to burn. So it slows down Juno enough so it could enter into Jupiter orbit insertion. So that's really cool. This is something that Celestia doesn't have, just because they don't have all that information quite available. So let me zoom back out again. Above Jupiter, that's what I want. Whoa, that's a little bit too far above, but okay, here comes Juno from the south. Let me speed up time again. So yeah, it's going to come on this really wild and wide orbit, and it's going to do, I believe, 33 of these orbits in total. What's this? I don't want to click any buttons and be sent back to launch, but it's planned to be doing 33 orbits over the time of the year, and that's simply because they expect in each orbit it's going to dip below that very strong radiation field, and every time it does that, it's going to add wear and tear to Juno and its instruments. So they only imagine its life expectancy will be for 33 orbits. And if it turns out that it's, whoa, this is a lot bigger of an orbit than I thought. And if it turns out it can last longer than that, they might extend the mission. We all know the Mars exploration rovers have lasted far beyond their 90-day planned lifespan to over almost 9 years here. But let me bring Juno back in. Whoa, see, it's in this really weird elliptical orbit that actually it shifts every orbit slightly. And every time it gets close, it's taking measurements. And let me see if I can time that. Nope, I didn't time that too well. Let me get it on its next orbit. And the reason it's in this orbit is it's always going to be having its solar panels facing the sun. It's never going to be behind Jupiter. So that is kind of a... Whoop, there we go. Hello, Juno. I want to click on you. There we go. Juno's going to get pretty dang close. And as you can see, that's the solar panels. They're always going to be facing the sun, no matter what. And a cool thing about Juno is it's always rotating like this. So what they did is they put all the instruments on the faces of this hexagon here. Hexagon? Is that a hexagon? Or a something gon? It's a geometric shape. All the instruments are on these panels on the outside, so that in each time it rotates, each of these instruments get a chance to take their readings every time they're facing Jupiter. So that was a really cool engineering problem that they solved. They also had to solve the fact that there are star trackers that track the stars in the sky, and that's how it can tell where it is in its orbit and in its trajectory. So that's really cool. But yeah, it's a really neat mission, and we're going to learn all about the interior, hopefully the interior of Jupiter, what makes up its core. They imagine it's a, what did they say? It's a metallic liquid hydrogen, or a solid hydrogen core, which is just crazy sauce. But with any element, hydrogen being the lightest, we think of hydrogen as a gas here on Earth, obviously. We can also make hydrogen a liquid, because that is what launches rockets, and space shuttles have a liquid hydrogen oxygen fuel. But under the density of the gravity of Jupiter, any object could become a solid, even hydrogen. So that's just kind of boggles the mind that you can have a metallic hydrogen, but it's quite possible in the core of Jupiter. And that's just one of the many amazing things they're going to be studying. I'm not going to start rattling off my mouth, because I'm afraid I'm going to say something incorrect and get completely spammed in the comments about how incorrect I am. But let me zoom back out. Let me look above Jupiter. Let me get a neat view of this orbit again, and let me fast forward past its 33 orbits, taking information, sending it back. Very exciting when this happens. 2016 is a very exciting year. Obviously in 2015 is when New Horizons is going to go by Pluto, so we're going to learn all about Pluto for the first time. Whoop, there was Juno. I thought I lost it. But after these 33 orbits, as you can see, the orbit keeps going more north than north there. I think that's north. After those 33 orbits, they are going to... Let me actually rewind that a little bit. Whoop, dang it. There we go. Okay. After those 33 orbits, they are going to deorbit Juno into Jupiter, ultimately to be crushed by its gravity and destroyed by... Let's zoom in and watch the plunge here. That's basically just so that they don't have a dead spacecraft endlessly in orbit there, and who knows where it would end up or what it would do. But they're also going to try to take readings as long as Juno will allow them. They're not expecting to learn much beyond the cloud layers. They sent Galileo, was a previous Jupiter spacecraft that at the end of its mission they sent into the Jupiter's clouds, and they didn't get any information from that, so they're not anticipating getting any information from Juno as it enters the atmosphere of Jupiter. But it's kind of a fitting end. And they do include, as a symbolic gesture on Juno, there is, I don't know if they have it here, but there's a plaque with one of, is that supposed to be it? I don't know, with one of Galileo's, symbolic to Galileo, since he was the one who, quote-unquote, discovered the Galilean moons of Jupiter and just, kind of theorized about other planets having moons and the orbits, and kind of getting away from a geocentric to a heliocentric view of the solar system. So there's that. They also have a few Lego figurines, one of which is modeled after Galileo, which is kind of cool. Also, there's 3 Lego going to Jupiter. So it's really kind of a cool mission, and I certainly encourage everybody to follow the Juno mission on Twitter. They also have a YouTube page that'll give updates and interviews with the scientists and whatnot. So I strongly recommend everybody checks it out. And also, in about a week here, there's going to be another NASA tweet up. All the participants have already been selected, but this is for the... Let me put Juno into Jupiter here. The end. Okay. There's also... Let me see if I can get out of here. Oops. Aha! Here we go. There's also going to be... I am still in Jupiter here. Let me pause for a second, and I'll be back with some additional content here and a final fair... Oop, did I figure it out? I figured it out! Exit to Eyes of the Solar System. Derp. Let me go back to now, current time, and let me look at a spacecraft. They don't seem to have. Where's Earth? Let's go to Earth. Click to zoom. Anyway, there's going to be another NASA tweet up in about a week here for the Grail mission. They're sending 2 satellites to study the gravitational field of the moon. So certainly follow along on Twitter if you can to the Grail NASA tweet up. But then also, they haven't announced it yet, but I encourage everybody to, if you haven't joined Twitter and you're interested in this stuff, feel free to join Twitter. But if you are on Twitter already, follow the user NASA tweet up, because they're going to announce a 3rd NASA tweet up, this one for the Mars Science Laboratory, which is the new Mars rover that's obviously headed to Mars. Mars. But that is going to launch in November, and that one is going to be very popular. A lot of people are going to sign up for that one, so I would recommend you check that out if you're the least bit interested in NASA or space exploration, astronomy. It was a great experience. Got to meet a lot of cool people, or as many people as the introvert Kurt can meet. Introvert Kurt, it rhymes. Trademark. But anyway, this was a hopefully brief, I'm not sure how long this is going to be after chopping it up, but a brief introduction into the NASA tweet up and Juno, and a little tour of the Eyes on the Solar System program. I hope you enjoyed it. Certainly let me know what you think in the video comments here. Certainly, if you aren't already, you can follow me on Twitter. It's Kurt J. Mack. That is the pseudonym that I went to the NASA tweet up under, and you can look past into some of my photos I posted there. I will also give you a link to the post tweet up video I uploaded here to YouTube if you haven't seen that yet. It's very interesting. We got to tour the entire Kennedy Space Center, got a close-up view of Discovery sitting in the VAB, and close-up view of the Atlas V that was about to launch Juno the next day, and of course the launch itself. So it was a very great experience. I'm just rambling on at this point, just lovey-dovey about the NASA tweet up. So certainly, if you can, I would recommend signing up for, and if you can make it, going to a NASA tweet up in the future. If you have any questions, certainly ask me. I'd be happy to answer some questions. But anyway, thank you for joining me. I'm going to zoom out of the solar system and out of, I think I can go out of the galaxy here too. Hooray! Whoop, speed ahead, Captain. Thank you for joining me. My name is Kurt. I will see you next time. Pew, 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 pew.